Okay, at the end of class on Friday, we were learning about the law of conservation of momentum. And what the law of conservation of momentum says is that momentum can be neither created nor destroyed, that the total momentum before an event or an incident must be equal to the total momentum after. So if we're thinking about a collision, like two of you running towards each other and colliding, you each have separate momentum before, so m1v1 initial for one of you, plus m2v2 initial for the other one of you, and maybe there's really 6 of you that want to collide and run. So we would put the ... there to say for however many other particles that might be involved in this collision will equal m1v1 final plus m2v2 final plus the ... for the others. So the total momentum before must be equal to the total momentum after. It doesn't mean, though, that m1v1 initial has to equal m1v1 final. There can be an exchange of momentum among the particles. It's just the total before must equal the total after. And when we go to use the equation, we don't put the dots in. We just write down however many terms we need for the particular question. And really, there are 3 different types of collisions, maybe 4. I think I missed one here. And you have this sheet. I gave it to you on Friday. So one type is if both are moving, like 2 cars crashing into each other. Another type is when one is moving and one is at rest, like when a billiard ball hits another ball on the table. And another one is when they are both at rest. Okay, if they're both at rest, we often call them explosions, like a bullet in a gun, or a person on a raft in Killarney Lake diving off the raft, a diver in a diving board, a person jumping out of a canoe. Initially, they're both at rest, but then after the collision, they move away from each other. And the one I didn't put here, and it could be, it's kind of a sub of either of the first 2, and that is when the 2 objects collide and stick together. And it could be that they were both moving initially, or it could be one was moving and one wasn't. But they collide and stick together after the collision. And you often see this in like a car crash. And the sticking together means they'll have the same final velocity, which actually will make our life easier when we go to solve for it. Okay? So same final velocity. So on the sheet I gave you, there were 4 examples, and this is what we would have done together in class today. So let's take a look. So a 100 kilogram car, so 100 kgs, traveling, so V1 initial, 24 meters per second east, strikes an 80 kilogram cart initially at rest. So here's my 80 kilogram dude. V2I is 0. After the collision, the 100 kilogram car is still traveling east, but only 10 meters per second. So V1F is 10 meters per second east, and the question wants you to find V2F. Okay, so we write down our equation, M1V1 initial plus M2V2 initial will equal M1V1 final plus M2V2 final. And it says the second guy wasn't moving initially, so this goes to 0. And we're looking for V2F, so we're going to take this guy over. So it's going to become M1V1 initial minus M1V1 final equals M2V2 final. Solving for V2 final, so divide by M2. So V2 final will equal M1V1 initial minus M1V1 final divided by M2. So M1, 100 kilograms, V1 initial, 24 meters per second, minus M1, 100 kilograms, minus V1 final, so 10 meters per second, divided by M2, 80 kilograms. So on the top, 14 2 zeros divided by 80, so 140 divided by 8 should be 17.5. So V2 final equals 17.5 meters per second. It worked out to be positive, So it must be east because we were calling east positive. Okay, example 2. A car moving north. So it's 5 kilograms, V1 initial, 2 meters per second north. Collides with an 8 kilogram car, moving 4 meters per second south. So V2 initial, 4 meters per second south. So right away you have to think, oh, I'm going to have to look after these directions. One's going to need to be negative when I put it in. After the collision, the 5 kilogram car rebounds. If it rebounds and it was going north, now it's going to be going south. So V1 final is going to be, was it 1? 1 meter per second south. And it wants to know what's V2 final. So M1 V1 initial, M2 V2 initial equals M1 V1 final, M2 V2 final. Assuming we call south negative, and north will be positive, and we're looking for V2 final. So bring this term over, nothing goes to 0 this time. So M1 V1 plus M2 V2 minus M1 V1 F equals V2F divided by M2. So we have our initial terms and our final. So V2F will equal M1 was 5 kilograms, initial 2 meters per second north, it goes in as a positive, plus M2, 8 kilograms, 4 meters per second south, so it goes in as a negative, minus M1, 5 kilograms, rebounding 1 meter per second south, so it goes in as a negative, divided by, what was it, 8 kilograms. So 10 minus 32 is minus 22, plus 5 is 17, 17 divided by 8. V2F should be negative 2.125 meters per second. So in other words, 2.125 meters per second. And the negative means south, or you could just do this and put a south here. Okay, number 2. Number 3, a 200 kilogram car, initially moving 5, so V1 initial, 5.8 meters per second, collides with a second car, 225 kilograms, initially stationary, V2I, 0. After the collision, they lock together. So after they collide, they move off like this. And you want to find the VF. So M1 V1 initial plus M2 V2 initial equals M1 plus M2 V final, because they have a common velocity. And this goes to 0. And we're looking for this VF. So VF is equal to M1 V1 initial divided by M1 plus M2. So 200 kilograms, 5.8 meters per second over 200 kilograms plus 225 kilograms. And you get 2.7294 meters per second, same direction. Okay? Backside. One more. 2 figure skaters, mass 50 kilograms and 80 kilograms, stand connected on the ice, and then they push off each other. So initially V1 initial is 0, and V2 initial is 0. As the music begins, they push off each other. So this is number 1, the 50. This is number 2, the 80. The 80 kilogram skater moves with a speed of 1.5 meters per second east. So V2F, 1.5 meters per second east. And it wants to know what's V1F. Okay, so we write our equation down. Plus, and the whole first side is going to go to 0. And so over here you'll have M1 V1F plus M2 V2F, and then you're going to solve for V1F. Take it over.